Good evening, everyone, and welcome to this evening's APM webinar, Drones for Project Managers. It's great that you could join us this evening and hear the presentation from Andy, Pete, and Tim. My name's Robert Allen. I'm APM Branches Manager, and it's great to see you here tonight. Please submit any questions that you have via your control panel, and we'll happily answer those at the end. There's also going to be some interaction during tonight's webinar. So I would be grateful if you could load up another web page with Slido, and when you get there, input code 52330. There'll be some polls throughout the presentation. We'd be grateful for your interaction. I'll also post those details within the chat function for you to see. So you're not here to listen to myself. So on that note, I'm going to pass over to Tim. I'd also like to thank the volunteers of the APM London branch for all your efforts. Tim, over to you.
Thank you very much, Rob. To start the presentation, and thank you to the APM for allowing us this opportunity to demonstrate how drones can be an effective tool in the armory of the project manager. A suitable drone with appropriate onboard equipment and a skilled operator can be a huge benefit for your project. And during the presentation, we hope to demonstrate how you could save time, reduce costs, improve quality and communication, and potentially reduce risk. Next. I own and run a project management training company, It's a Factor, and we provide a wide range of project management related qualifications. I kind of meet many project managers on our courses, some of them already using drones. And it's during many of our conversations that it became obvious that drone technology can be a huge benefit for many different types of project. And I became hooked on the benefits of drones and drone technology. And we hope during this presentation to enlighten you about drones in the limited time we have for this presentation. Next. Here are a few topics that we're going to have a look at today. The benefits, we can hopefully get those over to you. The capability, the legislation, and how you could implement drone technology into your projects. Next. In this presentation, we're going to focus on how drones can be used in the construction industry primarily. However, drones can be utilized across many business categories. And here are a few different categories that we're suggesting. Next. Please submit any questions in the chat. At the very end, we'll leave our website for you to follow, ipsofactor.uk.com. And if you go to services and drones, there's a form there that you can fill out to communicate with us further and find out more information. So I'll now hand you over to Peter, who will start with an overview. Thank you, Peter.
Thanks, Tim, and I'd like to thank Tim and the APM and all of you out there at home watching. What I'm going to do is, as Tim suggests, I'm going to introduce Consortic and let you know who we are, and then I'll go more into what's pertinent to you guys as project managers, and you'll be able to give us some feedback on where you see you might be able to use drones, or where you are on the whole journey of providing drone services, or you're interested in what drones can do, or in fact, indeed, you're delivering drone services. So I'll introduce ourselves here very quickly. These are the companies we provided a range of services for, ranging from train the trainer to consultancy to discussing regulatory impacts. It's a fairly broad range of organizations here, and we cover a whole range of industries and organizations. So if we move on to the next slide. As project managers, you will no doubt have had several internal meetings with stakeholders, and will have a whole series of things you want from delivering a project. And you will have different stakeholders, you'll have different people in the organization that might want something different from a drone operation. So as you can see here, you'll have some of these, if not all of these things in your minds when you're going to the project meeting, and then you might be starting to think about drone operations. When you come to that point, you'll be able to deliver a scope of work to these two guys on the right who will be using the drones to deliver imagery and data services that you can then benefit from. We then pass that back to you, and then you can disperse these widely in your organizations. These might be media teams, they might be your engineering teams, your architects, your maintenance people, even your logistics people. There'll be a whole range of things. And by operating the drones, you will be able to pick up a whole series of different data points. Next slide, please. And what we're going to talk about is going to give you an overview of drones and drone technology. We're going to give you some idea of what you can do in surveys and surveillance, building inspections, and things like a LiDAR and photogrammetry, and we'll explain to you what those are. We'll discuss briefly how to use drones as a service, or if you want to set up your own drone team within your organization. A quick discussion about the regulatory effects and requirements, and it goes on to drone training. And at the end, we'll have a question and answer session, which we think will be able to give you an idea, a good scope of where you want to be with your drone journey. In this talk, we'll use the word drone. There's also, you'll have seen UAV, unmanned airborne vehicles, UAS, unmanned airborne systems. The systems usually means that you're talking about the sensors that the drones are carrying as well. But drones is the more commonly used term, and throughout this briefing, I'll be using the word drone on most occasions. Next slide, please. So we're trying to figure out where your pain points are. So we're going to try and take you from this red zone of, can we use drones? Are we using drones? Are we getting the best from the drone and drone technology? And we're going to try and move you into that happy green zone, which we will hopefully give you some comfort when you get to that point there. Next slide, please, Andy. So as I say, this is an overview of airborne drones and drone technology. We're using airborne drones because that's the type of drones most of you will see, even though there are certainly land vehicles, not just the Tesla, that can be driven without any hands, but also you have underwater drones, the ROVs as they're called. But this is going to be talking mostly about the airborne drones, because I think that'll impact most of you people, but please, for sure, please let us know if there's anything specific in terms of underwater, on water, or even on land type drones. But I'm going to talk about the overview of airborne drones. Now, drones are normally divided into fixed wing and rotary wing types. And the fixed wing, as you can see here on the right, is very good for endurance and carrying certain payloads. It's good for long projects like roads, rail, pipelines. And you're talking about drones that will operate from something like maybe 30 minutes up to 12 hours. In fact, there are even some drones that can operate for 18 hours, but they're kind of getting to the military type drones there. But depending on what you need for a long survey or regular runs or something, then a fixed wing drone is where you're going to be looking at. And that'll carry a certain type of sensor in many occasions. Next slide, please, Andy. We now move on to the rotary wing drones, which are the more common drones you will see. The rotary wing drones are smaller, they can operate from more confined or congested areas, they're more maneuverable, and they can hover and hold positions, so you can get a very good fix on a certain aspect of a building or a site. Their flight duration is between 20 and 30 minutes. There are some other drones which can extend that time period. And they offer a range of sensors. Some of the drones will carry 2 types of sensors, but they're the most commonly used ones we think on most projects, and certainly in construction sites. Next slide, Andy, please. Then we have what's called VTOL, vertical takeoff landing drones. So these blend the benefits of a rotary wing drone to a fixed wing drone. So you can operate in a fairly small space, maybe a congested area. You can take off straight up and then transition to regular normal flight. So you have a benefit of small confined congested area takeoff, but you have the other benefits, which would be duration. So these can fly slightly longer. They're often used in terms of you're operating these in mining sites or big logistic sites or gravel pits. You may well see these surveying the land and scoping out the area. Next slide, please, Andy. Now, as I said, the drone is really carrying a sensor, and the sensors are linked to the type of applications you want. And the type of applications you want are linked into the industries you have. So really, we're looking at the sorts of payload which are typical for your application, which may be related to your industry. So there's a there's a sort of swaying back and fro between those three types of areas there. The type of drone depends on the application you need, depending on the industry. The oil and gas industry may well need certain drones which are good for methane sniffing, for example. They may need to look at a complex refinery area, which might be very different to a drone that might be required for a construction area, where you're looking at the roads going into this area. You're looking at the environmental impact. You're looking at mapping and surveying, or just photography for the media side of the drone team that you have back at your offices. Next slide, please, Andy. So how can drones help you and your project? How can we move you and your team, and also maybe your customers or your internal customers, into that green zone where everybody's comfortable in knowing what can be realistically expected by drones? So next slide, please, Andy. So where are we now? Well, even with this global uncertainty that's going around here, the drone technology is moving forward at a significant pace. And we are benefiting, if you like, the drone technology is benefiting from the investment that was made in a lot of the military drones that we used over the last decade or 2 decades, almost. So that's come spinning back into the commercial business here. And as we build this technology, the drones are becoming more affordable, more accessible, and as the benefits are being seen, they're developing more payloads or sensors. As this becomes more available and more widely used, then the regulations are coming in to make sure drones are being used safely, responsibly, and legally. And the two main organizations are in that, the civil aviation authorities and the European Worthiness and Air Safety Authority and the International Civil Aviation Organization. They have teams looking at the impact of drones in manned airspace. As we all know from the Gatwick experience, you don't want too many drones floating around a very busy airport. But in fact, there is now a drone corridor which will be working on the Thames, the regulatory authorities here in the UK, which I will say have really got ahead of the game, I think, over the years, and were leading in terms of taking drone and drone technology in and working it into the civil aviation authorities. Now, as these drones are gathering data and information, so the amount of information that's being gathered is also accumulating and growing very largely. So you can get enormous amounts of information from a 20 or 30-minute drone flight. And as this data comes in, you have to think, can our own servers handle the amount of information? Or do we have to go out into the cloud and put the stuff into the cloud and have a cloud server where also we can access the more up-to-date software? So if you have a large lot of data, you can end up using a software package in the cloud, and that will bring you back a 3D model for something like town planning. So we've discovered recently, where we were talking to a customer, where the problem was what they do with the data. Do they want the whole raw data, loads of gigabytes of points of information, or do they actually want a completed package? So that's something which you can either do a complete package on your own servers, or you put it out there and you work in secure cloud data processing and deliver the end package. The accuracy of that data capture and data sets is improving rapidly. As more and more software becomes developed, then we gather this raw data and we can produce some pretty amazing and spectacular images. And Andy will demonstrate that in a short while. We have to present data in an industry acceptable standard. So different industries will have different requirements on how many megapixels it has or what can be done with the imaging, but there are standards certainly which we can deliver data to you. Now, what we're interested in doing, and part of the poll we're saying, we're quite interested in where you are as individuals, as companies, in the use of drones. If you could just respond to us either on the messages which Rob sent you earlier. We would like to know if your organizations fit into investigating the viability of drones. Can you use it in your organization? Would you like to know more about where you could use it in your organization? Are you currently using contractors and getting drones in use, and are you getting packages and all the requirements you need from the drone operators. So if you're using drones in your company, we'd be very interested in knowing that. Are you developing an in-house team? That would be quite interesting for us. And what are you looking for from your in-house team? And have you not even considered the use of drones? Do you not know the benefits of drones? Would you like to know more about this? And because this is quite a new technology, relatively new technology, there are certainly some misconceptions, but there's also some big information packages people are missing because they don't know what drones can do. So if you could just let us know where you are on that sliding scale, we could maybe tailor some of the subsequent presentations to yourselves. And even at the end of this briefing, actually, in the Q&As, we'd certainly like to know where people are in their drone journey. Okay, next one, please, Andy. Okay, so as project managers, you're probably under the pressure to keep the thing under budget. I'm sure everybody would like that. You want it on time, and you want it available to quality audits. So we're going to suggest to you how drones can actually help you hit those 3 points. Next one, please, Andy. So how much do you invest or budget per project for innovation? How much is your team going to spend on getting and wanting to see this return on investment for the deliverables, such as great imagery, such as digital twinning of a building? Grant Shapps on April the 21st, in fact, mentioned that the British government's going to spend £21 million to assist in the fight against COVID. And that significant amount they put in there gave us the opportunity to stick our good friend here, Michael, on top of the roof in Southampton, where they're looking at using drones to deliver samples for the COVID response. This will be an ongoing project that's out there called the Future Airlift Project, or the Nesta project, and we can talk about that a little bit. But that's the sort of investment we've had from the British government to look at using of drones to benefit the current COVID crisis, which may be of interest to you. If you want to discuss that later, we can do that. Okay, Andy, next one, please. So what's possible with a drone operation? Well, you can get weekly visibility of a project. If you have a site, a work site, a building site, if you have a construction site, we can put a drone up in the air and it'll be in exactly the same place, exactly the same image, and you can see the progresses of how the building's going. And again, we'll demonstrate an example of that. But by using GPS, we can get a very tight fix on your imaging. So you can run through a whole series of the progresses, weekly progresses, monthly progresses. It's part of your requirement. So a single site visit, you could produce updates for you. You could be sitting back in your office and we can send you live feeds. We can land the drone, we can send you live feeds back on that. So the drone operator will have your scope of work, will give you imagery, and you will be able to look, that's how the job is progressing. We can give you ideas of volumetric surveys, which would be how much of that pile of spoil is there? How much is the gravel that's there? How much is how much environmental water is we damaging, or how much are we protecting? So we can give you a whole series of images, and we can analyze quite specifically volumes, we can analyze pathways, we can give you digital content for your social media. So you have a record of how you have been working on a site, a construction site, and you've taken all these precautions, and suddenly, as today, terrific floods came in, terrible rainstorms came in, and gave you exceptional circumstances. But in the lead to that moment, you have a history of all the protections you were taking. Now, what can also happen with drone imaging, you can reduce the costs of inspections, because you don't have to have such big teams there. You don't have to have scaffolding there. You don't have to have maybe a whole series of independent parts of your stakeholders who are coming there to get views. If you have a drone on a site and it's operating, somebody could say, we need an image of a certain part of that. We can fly the drone to that image and we get you an image and we can feed it straight back to your office. The live feed, somebody might say, the engineering department might say, oh, I'd like to sort of walk over to that area over there and just get a view of the trucks coming into the area. Or I'd like to get a view of where the power plant is or where the environmental teams are. So you don't have to spend so many people, so much time and so much money sending people to the one site. You're getting all the visual imaging there and then. As I mentioned earlier, we get a pretty good idea, and we know from some of the customers we've been involved in for sure. If you have huge spoil piles or even gravel piles, we can quite accurately calculate how much soil or gravel is in a pile like that. We give you the volumes to cubic meters. Then you can base the number of trucks you need to withdraw those that spoil away from the site. So you'd reduce the number of trucks that might turn up and leave half empty. You can use inspection footage to preventative maintenance. So, for example, if you fly a building, you could look at the building and notice those cracks appearing, and you can then get ahead of the game and fill the cracks up, stop the water ingress. We can do that through thermography. So you might have an area which is not reflecting light or reflecting heat in a different way, and that inspection could be vital in turning where's the water ingress, what's the problem here, where is the corrosion, and you can get to those points early, sort the problem out, and therefore you would be having maybe reduced impacts later on when the damage might be a bit more severe. Now, I'm quite keen on this one, the environmental impacts evaluations. Again, you will all be very aware that the environmental pressure groups are very keen on showing companies that they've done something wrong. And I go back to what I was saying earlier. You can actually say, no, we were doing things right. This is how we prepared things. This is how we're looking at the environmental impact. These are the number of trees we had here and we're protecting here. And you can have a history of what you're doing. And at the end of the project, you can show the benefits and the low impact your project might have, just through a series of photographs taken on a regular basis. Other environmental impacts, the impact of heat loss in a building. Insulation may well be required, and we can identify certain areas which may not be as well insulated, or indeed the construction teams and companies have not fulfilled their insulating obligations. And in fact, if I may use an example of one of the people we have met and we've been discussing drone services with, we're involved in a shopping area in the north of England, and when the winds came up last year, it ripped off some of the sidings. And on investigation, they found out that the constructor had not put enough fasteners in the sidings as per the initial requirement for the scope of work. When those sidings came off, there was supposed to be 15 fasteners per meter. I don't know the exact distance, but maybe per meter. There were only half of those were put in there. But not only that, it revealed that no insulation had been put behind the panels that had come off. So that cost them about $1 million to repair. Whereas the building survey with the drone would have had some pretty good images. The images are so good you could count the rivets or the fasteners on a particular siding. You would have been able to inspect the piles of the insulation material in the logistics yards and check the flow through of these insulating panels. And again, you'd have seen from thermography, you'd have seen heat loss in that area, and you could ask questions why before signing off. Okay, Andy, next one, please. So how do we do it? How do we do this? Well, we do reliable, repeatable data that comes through. And we are in the same spot every day as I suggested. So the same spot every day, you're getting the same images or the same weekly images. It's repeatable and it's reliable. The processing time is much quicker. And with the processing time, you will be able to get a live imagery, or even when we land, we can send the images off to you straight away so you can have a look at what we've produced, raw data images. The accuracy of our imaging is very, very good. There's an example of it there. Reducing the risk, reducing the number of manpower on site, reducing the need for scaffolding, reducing the people in high-risk circumstances. We improve the efficiencies. We believe we improve the inefficiencies, which may be caused by having too many people on a site, people not being able to use at one time or another. And so the timeline can be produced because you get a good visual image of where the project is here and now, and therefore you can send the teams to a certain site in the correct timeline. For cutting travel and accommodation costs, you may not need so many teams on the site at the same time. I'm sure you project managers are quite aware of how these teams can sometimes turn up in a place and maybe there's things aren't ready and right for them. We can give you live imaging, live data. Okay, so next slide, please, Andy. So I'm hoping by what I'm talking about now, we're taking you back in towards that green zone. And what I want to do now is hand you over to Andy, who's going to give you much more specific details on the more technical side of what we do and how we go about things. Andy, do you want to just quickly introduce yourself as you start picking this bit and telling them some of your background and your position now?
Yeah, sure. Good evening, everybody. Andy Huggett. I spent the last 30 odd years as a police officer, and before that I was a British Army soldier. But towards the end of my police career, I actually flew the police drones and worked with the police helicopter unit. So I've got a bit of a background in aviation. I set up my own company operating an aircraft and actually did my training through Consortic, which is how I ended up sort of meeting the team at Consortic. And over the last 5 years, I've ended up as the training manager in charge of Europe, Middle East and Africa, and also the chief pilot for Consortic and our sister company, Diplomat Autonomous Systems. I've got countless hours on all types of the aircraft, so hopefully I kind of know what I'm talking about a little bit. Unfortunately, both Tim and Peter seem to have prepared very, very nicely for this and seem to be looking at notes and all sorts. I'm afraid you've got to put up with me winging it, so it's just going to be my knowledge, I'm afraid. But I'm fairly good at talking, so hopefully we'll see how it goes. Okay, so we've been talking a lot about surveys and surveillance. I thought the best thing I could do was actually to give you a bit of an example. Now, we had to do a job last year at an airfield down in Hampshire because it was a live job. I'll refer to it as Airport X, but there isn't that many in Hampshire, so we'll probably be able to work out where it was. Site's actually 700,000 metres squared, so it's a large area. And for sort of the purpose of my theoretical case study, if you like, I just want you to imagine they're going to extend their runway to the north. So the runway there that's running from bottom left up to top right, they want to extend it a bit further. Obviously, the first things that they're going to be considering is the architectural planning, planning permissions, local objections, all that sort of stuff. So they need to understand the site they've got. So how do we go about understanding the site? Well, the traditional method, the method that you're all probably used to deploying, is the surveyor. The man with the theodolite, man with sticks, walks around, does a good survey for you. I cannot put my hand on my heart and say I can do a better job than him. I can't. But I can probably do it quicker, and I can definitely get the same accuracy or greater. Not greater accuracy, greater resolution in what I do. Let's explain that. A surveyor would probably be working 1 metre grid, something like that, across a whole 700,000 metre square site. The image at the bottom there illustrates how I work. I'll take the unmanned airborne vehicle and I'll do multiple passes of photogrammetry. And what happens there is I take multiple images that all overlap. Now, people often ask me, why do I need the overlap? Why don't I just take photos that butt together? Because you just want the image. By taking with multiple overlap, we're allowed to do a lot of very clever calculations in the background on the servers that allow us to do an awful lot of processing and do a lot with it, which I'll talk about in a second. If we compare the two different sorts of surveying then, a ground surveyor to do that airfield would have taken 5 days or more to survey that site. Could probably have given you some form of product in its rawish form within a day or so after that. Would have been very highly accurate, but the resolution would have been relatively low because we're talking 1 metre square, big 6-foot block, something like that. It's repeatable in that we've all seen where the surveyors go out, put down their control points, spray the ground with their aerosol can, nice fluorescent bits of paint. But if they want to go out and repeat it, they've got to walk the whole site. They're going to go around that whole 700,000 metre site again, walking around, driving around, whatever, but taking the survey again. The risk to the operator, as far as I'm concerned, is unknown, because each time they're going out on the site, they are exposing themselves to the risk there. It could be a hostile environment. I don't mean people shooting at you and things like that. I mean, it could be chemically hazardous. There could be hazchem around. There could be boggy ground, trip, slip, fall hazards. Obviously, you're going to have the construction environment, so there's heavy machinery, things like that. But at the end, the benefit, the product that you get is known, it's understood. You know what you're doing with it. On the flip side, if I do it with an aircraft, I reckon I could do that airfield in 2 days max, just using basic technology. If I went in with some of my more complex RTK, PPK, which is real-time kinematics or post-production kinematics, I could actually probably do that within a day, and then within a couple of days, you would have your product. The accuracy, again, is very high. I can get the same accuracy as the surveyor, but now the resolution is much higher as well. So whereas the surveyor may have done 1 point in a metre square, I could probably do many thousands if necessary within that 1 metre square. This is where I really come into my own mode. My repeatability is very, very, very high. I can plan what's called a waypoint mission, where I can say the aircraft will fly to point X, Y, Z in the sky. It will sit at exactly that height. The camera will point in exactly this direction. The gimbal will be at exactly this degree of inclination, and we'll take a photo. That means every time I come, the aircraft will go to that point in space and take that photo again on all of the photos that I do. This means that I can then take all of that data. We can give you photogrammetric 3D models. We can do animations. We can do fly-throughs. We can do elevation heat maps. And because it's all digital, the entire product is shareable. I just want to make sure, I keep talking about surveys. I'm acutely aware that I'm a remote pilot. I'm not in the world of project management or anything like that. And a survey to me might not have the same definition as it does to you. So I just wanted to make sure, a survey to me is the precise science of determining positions in 2D and 3D space and the distance between them, so that we can get accurate modeling, accurate resolution that way. So that's what I'm talking about. As I said, I'm not more accurate than a surveyor. The clue's in the title. Their business is surveying, but I can be as accurate. And the benefits, well, getting the data up to 20 times faster is not uncommon, but we do excel in getting data from inaccessible locations. It might be due to terrain, it could be due to chemical pollution, hazchem, anything like that. But imagine a scenario where you're going to be putting a construction site in, but there is still an awful lot of trees and foliage and things like that. You'd be surprised. I can actually do something with that, and I'll show you a video in a second that illustrates how I can even get data when the foliage is still there. 400 hectares, quite possible to a fixed wing in one flight. So one hour flight, I could cover 400 hectares and get that detail for you. And surprisingly, I can operate day or night. I mean, obviously the night is not very good for getting visible light images, but if I'm flying thermal cameras, quite often flying at night is the best time to do it. During the day, I have what's called solar loading, where the sun is heating up all the items. And if it heats them up to the same temperature, the thermal camera just sees one level. At night, where everything's allowed to cool down, I actually get the natural emissivity of the individual structures and surfaces. That gives me a much better feel of what is going on with the temperatures. So day and night is, acutely possible with the aircraft. I keep emphasizing this repeatability and being able to fly waypoint missions. Why is that important? Well, being able to see the change over time, I feel, could be extremely beneficial to you guys. Not only can you do things with my police head on, like look at a pile of materials waiting to go on the site, and then a week later see how much is left in that pile, but actually more has gone than has been used on the site. We can start, looking at losses that way. Or we can actually monitor the correct amount is going in, as Peter said about the shopping centre up north that we looked at. What I've got a little video. It just shows how accurate we can be. If you think things like Clash of the Titans, the old stop frame animation videos that we all grew up and loved, this is frames taken from the aircraft over time, showing a building basically growing and the development of it. At the end of the video, it starts going coloured. That's where we're starting to look at the elevation, where the dark red is the highest point and the lighter colours get lower and lower. So this is a site developing over time, and you can see how the aircraft has been exactly the same location every time. And into the elevation map. I'll just play that again because I like that one. I'm sad like that, I do apologise. But I love the way you can watch it all develop over time. Now, that might be an update for stakeholders. It could just be shareholders even getting updated on the progress. They all want to know how the site is developing, and a picture paints 1,000 words. You could have this daily, weekly, monthly, bi-monthly, however often you wanted it, we could come in and fly it for you. That's absolutely not a problem. Building inspection and digitalisation is another area that we do excel at. You might not be starting the construction from the beginning. You might have a structure already that you have to do some form of maintenance on, or replace the cladding, something like that. This here is a building that I flew recently, again up in the Manchester area. Created a digital twin. So what is a digital twin? Well, I can create a model that can be viewed from any angle that lives in the digital environment. It lives in the computer. But the thing about it is it's a photogrammetric model, so it's actually accurate. You can take measurements from it, you can view it, you can see updates on it, you can manipulate it, you can do what you want to do with it without having to put scaffolding all up the side of the building, and the inherent costs and risks that that would have as well. There's other things that you can do with it as well. I mean, the beauty of being able to 3D model somewhere, if we think the image down on the bottom right looks like a stable block or something like that to me, but if that was going to have an extension and the locals were complaining and objecting to it, I dealt with a case where a university wished to expand and was building additional wing and was running into an awful lot of planning objections. So we got a 3D model. What we did, we put the building into the model and then allowed the public to see it. And one of the main complainers, objectors to the planning, found that they couldn't actually see the building from their home. And they dropped all their objections there and then because they thought, well, it doesn't matter to me, I don't care anymore. And that was all down to the 3D model. So all that sort of stuff can be done. I was asked to talk a little bit about some of the equipment we carry as well. So LiDAR, FODAR, things like that for photogrammetry. We all know of radar, radio direction and ranging, World War II, what's and what, great. LiDAR and FODAR, they're all direction and ranging. LiDAR is light direction ranging, FODAR is photographic direction and ranging. And they're techniques that can be used for photogrammetry. So what is this ethereal photogrammetry I keep talking about? Well, it's a word that comes from 3 Greek words. Phos, or phot, meaning light, grammar, meaning letters or something drawn, and metrein, which is the noun of measuring. So basically, it's the ability to accurately measure off of drawings or photographs. So it's taking these photographs in a way that they can be manipulated, accurately measured, and things like that. So I'm using techniques, photogrammetric techniques, that allow me to produce survey accurate results for the 3D modeling, terrain maps, and things like that. LiDAR is an excellent tool for it. We all understand how the old radar system used to work. Radio wave goes out, reflection comes back. By knowing how fast the radio wave is traveling, we can work out how far away the object that it reflected off is. It's exactly the same with LiDAR, apart from the LiDAR is sending out usually somewhere between 150,000 and 300,000 pulses of laser per second. It's not only sending out between 150 and 300,000, but it's also receiving them and measuring the time taken for all of them. And recently, it's usually looking at the color reflection as well. So it's actually coloring every point that it gets back as well. This allows us to build highly accurate pictures just using these pulses of light. Now, what I've got next, it's actually an advert. I do apologize for the fact it's an advert. It's an advert for a new LiDAR system being flown by a DJI aircraft. Now, DJI have probably somewhere between 93 and 98% of the drone market in the world. So they kind of know what they're talking about as well. So I make no bones about the fact it's an advert, so it's a little bit pushy in that respect. But the bit I want you to listen out for, and it's only very short, they talk about what we can do when you get the foliage, the tree canopy is still there. And just listen to what we can do with the LiDAR.
Infrastructure assets like bridges, power lines, and towers can be modeled precisely by the L1, so you can operate and maintain them safely and efficiently. In heavily foliaged areas, its multi-return capability can penetrate vegetation canopies and capture point cloud data of ground features, as well as bare earth. Extract the vegetation point cloud to acquire information such as tree count, canopy width, and height. The remaining ground surface data can then be used to generate highly accurate digital elevation models or topographic maps.
So I didn't want to steal my own thunder earlier, but the LiDAR survey there, over the foliage, not only can we tell you how many trees have got to be removed, we can also tell you the biomass that's got to be removed. And even without the trees being removed, we can do the ground survey, we can do the lumps and bumps survey, give you an elevation map underneath. The image on the left here is actually a representation of a barn created just using the LiDAR point. So that's what we call a point cloud. It is a huge number of points in 3D space and the color return that the LiDAR got, giving us this absolutely accurate point cloud image. What we can then do, and what's used in the gaming industry and modeling industry a lot, we can do what's called polygon it, where we can work out the relationship between these points, how the photographs that we've taken can be assigned to their point in space, and thereby give us a photorealistic model that as we turn it round, the computer calculates that point's moved there, that point's moved there, so the photograph would have moved around like that, and it allows us to turn it round. So on the right, we've got the point cloud now basically wearing its photos. Now, all of the measurements on here have been done using FODAR, photographic direction and ranging. And the way this works, and it goes back to my original point, lots and lots of overlap. Because if you imagine, if I'm flying over a tall chimney, the top of the chimney between photographs moves a lot further than the bottom of the chimney. And the computer can look at that and go, well, all of these points have moved this far apart from this point, which has moved that far. I can therefore work out the height of it. So by having all this overlap, we can do all these complex calculations in the background to give us these 3D maps in their entirety. So what I wanted to show you here, how does this relate to a construction site? Well, here is a construction site that has been modeled. Now, what we've done here, we've created what's called the depth map. So on the depth map, we've got the point cloud, we've worked out the relative distances from the camera so that we can work out what's closest to us, what's furthest away, and build the 3D model. But it's not wearing its photographs. So it's not photorealistic, it's just the model. And the reason I wanted to show you this was it just illustrates how we can manipulate what we've got. And don't forget, this is highly accurate. We can still zoom in and take measurements on the ground. This porta cabin we've got coming next week, will it fit there? Can we take this bit out of there? How big is that pile over there? We can do all of that off of this model without actually having to go and visit the site again. So what I want to do now is just invite Pete back in just to talk about drones as a service and how you could deploy these capabilities to your projects. Peter.
Well, thanks, Andy. It always blows my mind when you start going into that stuff, and it's quite impressive. Your knowledge is very impressive as well. Anyway, let me talk about how do you get this sort of imaging and sort of work. Well, there's a couple of ways of doing this getting these images. So I mentioned earlier, one is to actually get drones, we call drones as a service. Now, drones as a service is where you get a company to come in and they do the drone work for you. They can do the flying for you. They can also add on things like the data interpretation, and depending on what you want, then they can go. A company might go out to outsource the drones, the drone flying, and then the software will be sorted out in-house in your own company, or maybe some of the companies which are out there will be able to interpret the data so you could get what you wanted, really. But you'd buy that service in, and you have what's called the pros and cons. If I can have the next slide, Andy. So the pros and cons. If you buy in the service, you can scale it up. You can scale for a single building. We need a rotary wing drone on that. We need to have a look at the access roads, the rail links, the pipelines going into these sort of areas. So you can scale it up by getting drones as a service. The upfront costs might actually be less. If you want a good quality and you're starting to think drones might be an option, then you need to get some decent bits of kit. For example, we spend £80,000 on our drones, so they're not necessarily cheap bits of kit, but they're certainly effective for some of the requirements. And we may well be able to put these over 4 or 5 or 6 customers. So each customer will have a different requirements, and we can move our drones into that sort of spot, for example. The liability. Drone operators, whoever you get in, would have to have liability insurance. These normally range from £5 million third-party liability right up to 15, 20 million pounds. One of our customers there, we showed you IAG. Actually, of course, you're operating drones in a hangar. You might well have a bit more expense, a bit more insurance you might need to cover. So the operator you'd bring in would have to go over things like standards. They'd have to be regulatory approved. They'd have to have the correct insurances. They'd have to have the right sort of training, and of course, the right sort of kit in certain areas. Drones as a service, you call someone into the job and they'd say, here we go, we can do the job. But of course, you would have some issues of your weather and environmental delays. The drones as a service guys will work around that and say, okay, we can operate here and now. We've contracted us to do the job. Here's the weather's coming really bad this week. We can fit this in as soon as we can. You're next in line to get the job done, or you're first in line to get the job done once you've issued a contract. The downside to that is that you can't just knock on a door, walk in and say, you guys get out there and take some footage of the shopping center we're building. The service company will have to go through their procedures to ensure the drone operation is safe, it's secure, it's legal. So there'll be some time lag, which from the time you issue the contract to the time that the job is done. And of course, you have a set scope of work for the contract, which, internally, if you had a drone team in, and I'll talk about that in a minute, you would be able to have some flexibility in the sort of things you'd want from a drone team. Now, as I mentioned earlier, the slight con, I suppose, or the downside of buying in the drone services would be the company would have to get their team together, the scope of work would have to be defined in contract, so all the administration process of employing and contracting a third party would have to be recognized and adhered to. Pricing structures are pretty well. Everyone, the operator will know the cost, they'll know how much they've got to do, what's got to happen before them, and of course we'll have a margin on that. So the pricing structures might be fairly rigid on a daily rate or part thereof, or maybe a weekly rate if you're going to send them out. Possibly even if it's a longer project, then there's a lot of other complications, but there are certain costs which you'd be charged for and have to sign off and have to pay for, of course. If your UAV needs are more complex, you don't have the in-house competency, it's best to get drones as a service, we believe. So you'd have to go out to the market and look who's out there. So we think that the drones as an in-house measure has certain benefits, but the drones as a service for more complicated areas might be a good source for getting your projects digitized. Next slide, please, Andy. Next slide, Andy. Sorry, is he gone? Is he there? So if you're creating you're creating your own drone program, you can maintain full control of the operation and the kit and the data and the imagery. You will have an immediate response time. Knock on the drone team's door. Let's get out there and have a look at what's going on. You can design the program, the people you have on board, to fit your department's teams perfectly. Your media team might want a weekly shot of a drone using that sort of camera and that sort of image. And that'll be known. Your engineering team might have a certain sensor they want fitted on, and your finance team may well want to sort of do some cost analysis using the images and how much does it cost and stuff. So you can have a very well-defined drone program inside, and you'll know your costs. Having your own drone team, you do of course have your legal liability responsibilities as well. So you would have to make sure your insurance is always maintained. You have to make sure that all your CAA regulations are met. And you also have to ensure, of course, your equipment is up to date and the service records of some of your equipment is maintained. And after a certain number of flights, you have to change the propellers, certain number of battery uses, you have to change the batteries. You have to keep an eye on all that sort of equipment. And again, as I mentioned, your upfront costs of maintenance and equipment replacement would also be there when you set up a team. So if you're going to need technology on a small scale, then maybe get your own drone program in, devise it. We'd certainly, companies like us would certainly help training you to get the legal requirements. And we also would add some advisory services around that. But if you wanted to do your own training, then let me take the next slide and give it back to Andy very briefly, and he'll give you a quick talk about drone training, as he is our drone chief training captain. So Andy, are you there?
Yeah, I'm there. I do love the way my job title changes every time you say it, buddy. Yeah, we obviously are a training provider as well. The law and the regulations currently require anybody operating an aircraft in UK airspace for what is ostensibly a commercial purpose to hold a permission from the CAA. And the only way that you can get that permission is to undertake a course of training with what's called an NQE, a National Qualifying Entity, or what is changing to be an RAE, Recognised Authorising Entity, to get the relevant paperwork to show that you're eligible to fly in UK airspace. I say it like that because we're in a little bit of a state of flux. The regulations actually change on the 31st of December, and we move from UK law over to European law to try and harmonise what we're doing. And in fact, the image on the screen there is our brand new General VLOS certificate course, ready for that change on the 1st of January. So, as I say, you have to have a permission at the moment. From the 1st of January, it won't be a permission from the CAA, but what will happen then, you will need to have an operational authorization, and it's all based on the risk that your operation will pose. Now, you can fly in what's going to be called the open category with a very small aircraft, very, very low risk, very low what they call kinetic energy impact value, how hard it's going to hit you if it falls out of the sky. And mitigate the risk away even further by saying, I'll keep a long way away from uninvolved persons. And the qualification that you need to hold is to have passed a 20-question multiple choice online exam and read the user's manual. That's it. That's the entire qualification. As you move up the risk and you start flying slightly heavier aircraft up to 4 kilos, and you're bringing the distance from uninvolved persons down, you move up into what's called the A2 category, and you need to hold an A2 certificate of competency, which is, it's about 11 hours of training and an examination to prove that you are competent to operate in that environment and under that category. An A2 C of C, certificate of competency, is issued. However, the one that most, what we term now, commercial operations would fall under will be the General VLOS certificate, the course study manual that I had on the screen there. which is very similar to the training that was provided up until now for the permission. About 20 to 25 hours pre-learning, followed by a 2-day ground school and an examination and an actual flight skills assessment based on the procedures that you have to develop to show that you're going to operate safely. If you want any more information about that, it's not really part of this presentation. You need to talk to an RAE, recognised authorising entity, and yet you can always talk to us. Consortic is one of those. But that's the end of the bit about current legislation and training requirements. So I'll hand you back to Peter at that point.
Thanks, Andy. So hopefully we've taken you from the red area here and we're bringing you back into the green zone so you understand a bit more about what drones can do and how they may benefit you. Next slide, please, Andy. So the nutshell, if you like, of what we're trying to say is that drones, UAVs, can provide remote sensing images, and a whole range of sensors can provide a whole range of data. The aircraft can fly quite precisely. They're fixed in by experienced operators and GPS systems. We can fly in inhospitable areas that may well be contaminated. They may well be dangerous, at high risk. Flooded areas, we can get across flood zones when the rains have stopped and we can deliver things. The future, I like this bit at the end, the future of UAVs in the industry sector is almost a given. Goldman Sachs reports, like the internet and GPS before them, drones are evolving beyond their military origin to become powerful business tools. And they're very powerful business tools. They're changing and developing and growing. And I think it's quite important that they're accepted into business and industry. We learn how to use this equipment, and we develop and we apply what we are using now to benefit industry. And I think you project managers will be in the right place for that. What I'll do now is I'll pass this back to Tim, who will wrap up, and we'll open it up for questions.
Great, thanks very much, Peter and Andy. I'm actually running an APM PMQ course at the moment, and I asked the delegates if they had any questions as well. But and hopefully we can just answer a couple of these before we just finally wrap up and answer some of the questions from any questions that's coming through the chat. But if maybe Andy could ask this one, answer this one. What are the associated risks when employing drones, and how can those risks be mitigated?
Yeah, I mean, it's a good question. The risks, if you like, are that of aircraft failure, obviously the airspace incursion, flying where you shouldn't, all the problems of flying in restricted airspace, flying during air shows, crashing into something, getting in the way of another aircraft, those sort of things. But by using qualified personnel, you can mitigate those risks right down. Obviously, part of the ground school training that we put remote pilots through is mission planning, mission planning, mission planning, mission planning. As with every other piece of aviation that's out there, it's all about checklists and procedures, standard operating procedures, mitigating that risk down. I personally, whenever I go out, regardless of if I've got anybody watching me or anything, I'm working to my checklist. There is no shame in getting my checklist out and going through going, yeah, I've done that, yeah, I've done that, yeah, I've done that. Even colleagues of mine, airline pilots, many thousands of hours experience, will use the checklist before they even flick a switch on a civil airliner. I'm no different when I operate the drone. The risks to the uninitiated, if you like, is considering them to be the toys, the old Macklin Man type. Well, my nephew got one of those for Christmas. I'm sure he can come and take those pictures for me quite safely. The risk to a corporation is you hold the vicarious liability of operating an aircraft in UK airspace. And if you're not doing it correctly, it's going to come down on you, not only for the legal risk, but the insured risk, the financial risk, and the safety risk, because nobody wants to end up hurting somebody.
Fantastic. Thanks, Andy. Another question was, how easy, for one of our project managers who is thinking about doing it themselves, how easy is it to keep up to date with legislation and drone technology?
Yeah, you have to be committed to it. It's not something that you can just pick up, learn, walk away from, come back to 6 months later and go, oh yeah, I'm still up to date. I'm registered on all sorts of different forums across all sorts of social media. I receive regular updates from the CIA. There's an app called Skywise, which is actually a CIA app where they put out their safety notices, their information notices, all that sort of stuff. You really do have to stay on top of it. And in fact, a well set up organization would have somebody in the role that I do, a chief pilot. One of my responsibilities is ensuring that all this wealth of information that's coming in is cascaded down to all of my pilots to ensure that the entire team is 100% up to date. So somebody who's coming in, not only have they got to learn how to operate the aircraft, how to operate the aircraft safely, how to plan the mission, how to fly the mission, they've also got to learn to operate in that environment with regards to the different data sources to get the information to make sure they're up to date as well.
Fantastic. Just one more question. This is a really good one. What is the feasibility of employing autonomous drones? So with no one involved.
Yeah, it is possible. Yeah, it is possible. There is far greater safety cases that have to be looked into for this. Currently, you have to have what's called VLOS on the aircraft, visual line of sight contact with the aircraft at all times, a person with control to do it. Obviously, we've demonstrated with things like Global Hawk Predator in the military environment, and recently with the Isle of Wight, things like that, we can operate unmanned aircraft beyond visual line of sight. The risks involved in it are obviously greater, so the mitigations that you put in have to be greater. To fly totally autonomous with no human input, it is possible, but what you'd have to do is do the training, build the safety case, and get the CAA to understand your safety case and agree to it. It's not something that you could just take out of the box and do.
Fantastic, Andy.
There is also, if I may just say something on that, there is also a case that in fact autonomous systems, something being controlled completely without human intervention may be safer, because there is a large element of human factors in accidents, as everybody knows. But the critical item in that is the planning and the preparation, the maintenance of the equipment will still have to be done by humans. So there's still a human element in that.
Fantastic. Thanks. I'm sure the course delegates will be pleased with those answers. Rob, should we pass this over to you so you could give us some of the questions that possibly been posed from the delegates?
Yeah, nice, certainly. But firstly, thank you, Andy, Peter, and Tim for sharing the knowledge and going through tonight's webinar. It's really great to learn new knowledge, and there's certainly some comments from people saying a great overview of the capabilities, certainly worth keeping in mind. Am I right in saying, Tim, the best slide for someone to contact you on is the information there, and I'm just about to post something in the chat as a...
Yeah, that's perfect. And that link in the chat, yeah, just on the right-hand side, if they click on the link, it should take us to our forms. And then if they wish to contact us for further information, then we would love to hear from you.
Perfect, thank you. So I'll move into a couple of questions. So Tiang asked about pilot competencies and certification of drones, and I believe, Andy, you covered that in part of your presentation. So Tiang, if we haven't answered that question, please repost it and I'll pose that to Andy again, or reach out to Tim on that contact form. Andy, Charles has asked, and it links to your weather-based question, really. You mentioned about temperatures playing a part on drones, and your preference, I guess, to fly at night. I don't know if Charles is based in the UK, but he talks about rain. Now, does rain have an impact on the quality or the performance of the drone?
Okay, just 2 points there. The temperature wasn't so much to do with the aircraft, that was to do with the solar loading for thermal sensors. I can operate most of my drones out of the box between -5 up to about 40 Celsius. Rain-wise, most aircraft are not rated to fly in any form of precipitation, but there are aircraft out there that you can actually land in the water and take off again that are totally waterproof. And in fact, the aircraft that I flew for the police was weatherproof and could fly in winds of up to 55 miles an hour. The drawback, of course, is, yeah, I can fly up there. I can go up to 400 foot in the rain, but I can't see anything. That's the big thing. So it's quite pointless me launching. However, some of the sensors that I might be carrying might want that environment. I might be looking for wind speed, air quality during the rain, anything like that. So yeah, there are aircraft that can fly in the rain. There are aircraft that can fly in pretty much any form of weather you can throw at them.
It does make the pilot more miserable when the thing's flying in the rain. That's what I have noticed, Andy, if I may say.
You mean me, don't you?
No, perfect, Andy. Thanks for the clarity around the temperature bit and expanding on the rain as well. Brian has asked, are the cost of surveys dropping, so we'll start seeing more use of them?
It depends on the scope of work, really. It depends what you're sort of talking about survey. The equipment you had 3 or 4 years ago, say, for example, a reasonably good entry-level drone was about £3,000 or £4,000. It's difficult to get batteries for those now, so they get redundancy in the system. But the performance and the quality of the drones you're getting and using, the prices may well go up, but the image quality you're getting is so much better, and the performance is so much better. What is happening is people are using the drones for bigger scopes of work. So it's difficult to say what sort of survey it is. Is the price dropping? Well, again, it depends. You could do a very cheap survey, but you get a good image on something with a sort of smaller drone. You could do that. Again, some of the drones are fairly good and fairly small. But from a bit of experience we've had, where somebody gets good imaging from the drone, and they say, "Oh, this is really, can it do that?" So, ironically, what's happening is they're getting initial imaging from an older drone in a cheap survey, but they're starting to see the benefits from these. So the cost of the survey might go up because the benefits they're getting might go up. So it's kind of a difficult one to answer, I think, that, because it depends on the complete scope of work.
I think what is happening is people don't know what the aircraft can do. It's the old adage of they don't know what they don't know. And as people are finding that the aircraft can do different things, we're being brought in to do more, and people are finding that actually we can be cheaper to get some of the other data that they want as well. So it's as broad as it is long. We come in, we do extra services that you haven't paid for before, but we can do the services that you do cheaper. So it's sort of all over the place. It's a chicken and the egg, which is a very hard question to answer.
Excellent. Thank you, Andy, and thank you, Peter. Brian, feel free to reach out to Tim if you need any additional information around the costs, etc. So there's definitely one more question that I can ask, and it says, currently drones are used to get into inaccessible areas, thermographic surveys, hotspots, etc. Are you potentially able to share other applications for drones?
Yeah, pretty much anything you can think of. Near enough every day somebody comes up with a new use for the aircraft, or they'll come to us and say, I want to do this, can you do it? And most practitioners out there are fairly expert in working out how to solve a problem. In fact, if you like problem solving, flying drones is the business to be in, because not only are you working out how to fit into the airspace and fly with the other aircraft, but more often than not, you're problem solving how to gain the data that somebody wants that hasn't been gained in this way before. So yeah, pretty much every sector out there, we could probably find uses in a multitude of areas.
Excellent. So certainly can help different sectors. I wouldn't mind just asking, what's been the, if you're allowed to share, the best location you've either stood in the rain, stood in the sun, stood in the snow, and actually used a drone? Is there one place that you go, oh, I'm delighted I went there?
I'm very proud of the fact that the company deployed me to Mozambique last year. I was actually out there following Cyclone Ida, doing humanitarian aid. they deployed us out there with a couple of thermal drones to support the humanitarian effort that was going on out there. So immensely proud of doing that. From a personal point of view, I love flying in the Nevada desert. It's just an awesomely spectacular place to fly. So there's my two.
I have to say, when I first had my drone about 5 years ago, I took Bramber Castle, which is a beautiful old bit of a ruined castle, and I flew my drone up and looked through the window, and I thought, no one's looked through that window for hundreds of years. And I was really quite pleased on doing that. And it still is memorable to me, that particular moment when you look at you get an angle of something no one's seen, for that view has not been seen for hundreds of years. So that one's still with me. And I like the Sussex countryside as well, so that was quite good.
They're an awesome thing because you get so involved in the flying and you're so involved in your telemetry and the feed from the aircraft that you're flying. I've actually given myself vertigo flying before, where I'm flying along and that's it, I'm at 400 foot and I'm starting to get scared of heights.
Good to know and good to share. Thank you. I think on that note, it looks like we've covered the questions that have been posed by the people in the room. So on behalf of the APM and the APM London branch, I'd like to say thank you to Peter, Andy and Tim for taking the time this evening.
Thank you, Rob.
Great. Thank you very much. We look forward to hearing any further questions, and thank everybody for tuning in.
Perfect. Thank you, Peter.
Thanks, Rob.
Not a problem. I'd like to express my thanks to everyone who's joined us this evening. I hope you keep well. We hope to see you at future APM webinars. The London branch have got some lined up in the near future on cyber threats, for example, and diabetes. And they've also got a virtual meetup to replace the networking and communication that you typically have at physical events. So we hope to see you at some soon. So as I say, on behalf of the APM, everyone, keep well and we'll see you soon. Bye for now.
Thank you. Bye-bye.